All right, let's get right into it. You've probably seen this yourself, right? A modern AI can whip up a poem, break down a super complex document, or even spit out lines of code. It feels really smart. But then you throw a seemingly simple logic puzzle at it, or maybe a math problem with a few steps, and it just completely faceplants. It's this huge contradiction. And that's the mystery we're going to unpack today, why this brilliant AI can fail in such baffling ways. And you know what? That quote is spot on. Their fluency is incredible. They sound so confident and articulate, and they lay out information in a way that makes you think you're talking to a real expert. Honestly, it's that level of polish that makes their weird mistakes so jarring. So that brings us to the big question. If these models can master something as messy and nuanced as human language, why in the world do they stumble when it comes to the clean, black and white rules of math, or coding, or logic? What's the missing piece in their so-called intelligence? To really get to the bottom of this, we've got to pop the hood and see what's going on inside. See, the answer isn't really about what these models know, it's all about how they learn. The secret to their genius and their failures is baked right into their training from day one. So, the training process usually happens in two big phases. First up is pre-training, which is where the AI basically just absorbs a giant chunk of the internet. Books, articles, websites, you name it, just to learn the rhythm and patterns of language. But it's that second step, supervised fine-tuning, or SFT for short, that's where things get really interesting for us. That's the key. So what in the world is SFT? Well, think of it like this. Imagine a student who's been given the complete answer key to every test they're ever going to take. They're not really learning the subject, they're just studying thousands of question and answer pairs that a teacher has marked as correct. The goal isn't to understand, it's just to get really, really good at producing an answer that looks exactly like the one on the key. Keep that analogy in mind, because it's everything. And here's where we see the disconnect. We assume the point of all this training is to teach the AI the actual rules of logic, the why behind the right answer. But what's really happening? The AI is just becoming an expert at mimicking the how. It's learning the statistical patterns of words and symbols that tend to show up in correct answers, without ever actually understanding the logic that connects them. And all of this leads to a pretty stunning conclusion. An AI's ability to reason is, for the most part, a performance. It's a master illusionist that has perfected the appearance of logical thinking without possessing the real thing. I mean, this quote just says it all, doesn't it? If you take one thing away from this, let it be this. The AI is basically an actor who's been trained to play the part of a brilliant mathematician. It knows all the lines, it knows how to scribble equations on the board and look thoughtful, but it has zero understanding of the deep mathematical principles behind the script. You've definitely seen this. You ask the AI a tough question, and it says something like, okay, let's think about this step by step. We see that, and we think, wow, it's showing its work, it's reasoning. But nope. It's just generating that phrase because it learned from the data that answers starting with step by step have a super high chance of being marked correct. It's all part of the performance. Okay, now this part is just wild. The way these models are graded is completely backwards. Just look at this. If a model follows a perfectly logical, brilliant process, but makes one tiny typo or calculation error at the very end, it gets penalized. But, and get this, if it uses completely garbage, nonsensical logic, but somehow stumbles into the right final number, it gets rewarded. The system is literally designed to prefer being lucky over being smart. So, where does this whole magic trick fall apart? Well, it breaks down the second it enters a world where just looking right isn't good enough. A world where you absolutely, positively have to be right. And that's where you see these epic fails. In things like high-level math, competitive coding, and formal logic puzzles. These are areas with zero wiggle room. The answers can be checked, and they're either right or they're wrong. There's no A for effort, and pure imitation just can't fake its way through. And here is the ultimate, mind-bending paradox of it all. A true genius, a real deep thinker, might come up with a totally new, elegant way to solve a problem. But if our AI did that, if it had a genuine moment of creative insight, it would actually get punished for it. Why? Because its novel solution doesn't perfectly match the one single method it memorized from its answer key. The system literally stamps out the very creativity we want it to have. So you might be thinking, okay, easy fix. Just give it more data. shovel in more examples of good reasoning. And that sounds logical. But it turns out that not only does that not fix the problem, it can actually make it a whole lot worse.
So why doesn't that work? Well, for one, getting humans to create thousands of perfect step-by-step reasoning examples is incredibly slow and expensive. But the bigger problem is that more data just forces the model to double down on being a good mimic. It tightens the grip of imitation, making it even less likely to ever explore or discover a new way of thinking for itself.
Okay, so if imitation is a dead end for getting to true reasoning, what's the alternative? Well, the research is pointing to a completely different way of teaching these models, a fundamental shift in how they learn to think. The missing piece of the puzzle seems to be what's called outcome-driven learning. So instead of just showing the model the final answer sheet, you let it actually try to solve problems on its own. You let it fail, let it try again, and let it learn based on whether the final outcome was a success. It's the difference between memorizing a picture of a solved Rubik's Cube and actually learning the moves to solve one yourself. And that leaves us with this huge, exciting question for the future. The next great leap in AI probably isn't about building bigger models or finding more data. It's about cracking this. It's about designing a system that doesn't just reward imitation, but rewards curiosity and exploration. So how do we teach a machine not just to repeat an answer, but to genuinely explore a problem? That's the next frontier.